Okay, so today we'll start the second chapter. So in the second chapter, we'll discuss about the different testing methods or different levels of testing, testing methods and different levels. Uh, so first we'll start with the two important methods of software testing, that is black box testing and white box testing. So these are very important type of uh, testing methods, black box and white box testing, that covers the different test cases for testing a particular software application. The approach for the black box testing is different and the white box testing is different. So there are different methods are there, different methods of white box testing and black box testing. Black box testing, it is also called as the functional testing, that checks the functionality of the software application. It is also called as functional testing. Black box testing is also called as a functional testing because it tests the functionality of the software application. And there are different types. The one is equivalence class partitioning, boundary value analysis, and cause effect graphing. These are three important types of black box testing method: equivalence class partitioning, boundary value analysis, and cause effect graphing. One more type of the method is called as white box testing. White box testing is also called as the structural testing. White box test method is also called as structural testing. So structural testing, the types are the coverage testing. So in that, statement coverage, branch and decision coverage, path coverage. So these are the different types of white box testing. So these different types of testing that covers the maximum errors, the maximum errors or defects in the software application. And at the last, we'll discuss about the difference, compare the difference between the white box and black box testing. So black box testing, that you already know, in black box testing, we just focus on the inputs. We just focus on the input and the output of the software system. So this is very important. These two methods that may ask in your interview also. So whenever the software testing method comes, so these two types are very important. The basic types you should know, what is black box testing and white box testing. These are all very basic questions for your interview. Basic questions for the interview. So input. So whatever you give the input, like for example, we are not bothering about this code and all. We are not bothering about. We are not looking the internal details. Suppose if the input is, you are providing 2 and 5, These are the two inputs that you are providing, and your particular module, it performs the operation of, like, for example, multiplication. Okay, we don't know, we are not bothering about the code or logic of how the module it perform the multiplication. The output should be 10. We are just we are just comparing the input and output. We are just comparing input and output of the software application. So in black box testing, we just focus on the input and output of the software system without bothering the about the internal, the knowledge of the software program, without bothering about the internal knowledge of the software program. So that is black box testing. So the black box is an executable program that can be any software system that you want to test. Any software system that you want to test. So we'll discuss some examples. There are some general examples. Like for example, black box testing means like input an integer and it prints it. Means you are providing an one input, and the code or this particular the module. Okay, this particular module, what it does, it generates this program. It gives one output. Hmm? So you are providing an input. For example, 14. The input, you are providing an input. If the input is that parameter, if it is less than the 1024, it prints that value. Else, it won't print. Okay. So this is simple. Just black box means this is the code. Whatever you are written, you are providing an input. Yes, 14. If the condition is true, then output it will print the value. So that is the black box testing. Suppose if you check the logic and all, the code, internal structure, if you analyze the step by step, then that is white box testing. That is white box testing. I hope you understood this executable program. So this is the executable program, and in this executable program, you are just you are not focusing, you are not analyzing any code here. You are just providing input and output. If you analyze the code and all, so that is white box testing. That is white box testing. So for example, this is a code. It takes the two numbers and the result. Okay. So in the black box testing means what? You are providing an input. Okay. Enter first number, second number. And what is the result? 25 for multiplication. Okay. Multiply the two numbers. Multiply two numbers. So this is the black box. And suppose for 5 into 5, if you are not getting 25, so you will check the some code and all. You will analyze the code, and that is called as white box testing. Okay, we'll discuss that on the types and all. White box testing means we will analyze the code. In this is a black box. You are providing an input and you are comparing with the output. So in your interview, if suppose if they ask a question, you should explain with the example. You should explain with the examples. So then only means they will come to know, okay, you understood the concept of testing. So that is some examples of black box testing. By applying the black box testing techniques, you derive a set of test cases that satisfy the following criteria. The test cases that reduce by a count that is greater than one the number of additional test cases that must be designed to achieve the reasonable testing. Means you need to reduce the test cases. For example, for a particular field, suppose if the age is a one field, and this age like for this particular age, the valid input is like from valid input is 19 to 60. Okay, 19 to 60. This is the valid input. Invalid means the 0 to 18 is invalid, 61 above is invalid. These are the two cases. Hmm. So here you need not write the test cases for all the input like 19, 20, 21, 22 up to 60. Okay, you need not write means for this test case. Test case means like for example for this one test case, if the input is 19, output is valid. Second test case, suppose if the input is 20, it is valid. So likewise, if you use to write for all the values, the number of test case will increase. Okay, so this is not the way. So that's why we use some black box testing techniques to reduce the number of test cases. Okay, because we know 19 to 60 means it is a valid inputs, means we have to check at least one input, like randomly we have to choose, like suppose 41. If you provide the 41 input, then it should take the, means it is valid. And suppose if we provide 9, and the system should means that particular application should say it's invalid. So instead of testing all value input, it will take more time. Okay, so black box testing means the testing methods that reduce the test cases, that reduces the test cases. We will see that the different methods. Test cases that will tell you something about the presence or absence, the presence or the absence of the classes of errors. Classes means the group of errors. Okay, in the range like 19 to 60. In this particular, this is one class or one group. So if you if you test with one value, it will say that okay, it is valid, or presence of error or absence of error. So the different types of the black box testing methods are equivalence class partitioning, boundary value analysis, and cause effect graphing. So equivalence class partitioning, boundary value analysis, and cause effect graphing. So boundary value analysis, that is extension of this equivalence class partitioning. Equivalence class, actually you can also call as equivalence partitioning or equivalence class partitioning. It is a software test design technique. Software test design technique. Software test design technique that involves the dividing the input values into a valid and invalid partitions. Okay, just now we discussed from the age group 19 to 60 are the valid, 0 to 18 are invalid, above 61 is invalid. Okay, so it partition the valid and invalid groups, valid and invalid groups by selecting a representative values, means one value. For example, in 19 to 60, suppose 42 is the representative value. Instead of checking all the values, we are checking with the only one representative value of in a group, representative value from the each partition as a test data. So equivalence partitioning means it is a software test design technique that involves dividing the input values into the valid and invalid partitions. Okay, valid and invalid partitions. So the example we'll discuss. One example is that, yes, this is the example. So what is the example? A text field that permits only the numerical characters, numerical values. Okay, it accepts only the numerical values. The length must be between the 6 to 8 characters or 8 character long, 8 numeric characters. partition according to the requirement, it should be like 6 to 10 range, means 6, 7, 8, 9, 10. So these five numbers are the valid inputs. Okay, 11 above, this is invalid. This is also invalid. Okay, so while evaluating the equivalence class partition, values in all the partitions are equivalent. That's why 0 to 5 are the equivalent. 6 means like number of values. Equivalence class, so that it is also like equivalence class means like the digits. Okay, 13, 12, 11, 12, 13, 14. And these are valid class and invalid class. Valid and invalid. So that is equivalence class partitioning. Okay, it will divide the input values into valid and invalid partitions. Then boundary value analysis. In boundary value analysis, it is a software test design technique that involves the determination of boundaries for the input values and selecting the values that are at the boundaries and just inside or outside of the boundaries as a test data. So for example, in this case, so these are the boundary values 6, 10. These are the boundary values. Okay, it is a software, it is also one of the test design technique that involve the determination of the boundaries, determination of the boundaries for the input values and selecting the values that are boundaries that are at the boundaries and just inside or outside of the boundaries. Even we can consider this also for invalid, we could consider these boundary values inside means this one, these two will come 6 and 10, and outside means these two, this one 5 and 11. Cause effect graphing. Cause effect means it is also one of the technique that involves identifying the cases, that is input conditions and effect. The cause and effect means because of the input, the effects, and producing a cause effect graph. We'll discuss with the example that generate the cases accordingly. So we'll discuss in detail the equivalence class partitioning. It is also called as equivalence partitioning is also called as equivalence class partitioning. Equivalence class partitioning. It can be applied at any levels of the testings, any levels of testing, and it often a good technique to use first. The idea behind this technique is to divide or partition, divide the input data. Okay, divide or partition a set of test conditions into the groups. Like groups means the valid or the invalid data, or the sets that can be considered the same. Okay, hence it is called as the equivalence partitioning. Equivalence partitioning is a testing technique where the input values are set into the classes. Like valid input class keeps all the valid inputs, and invalid means all the invalid inputs. Valid input class means it keeps all the valid inputs. Like in this case, 6 to 10 are the valid inputs. Invalid class means 0 to 5 and 11 to 14. Okay, invalid input classes. Then equivalent class partitioning that may be defined according to the following guidelines. If the input condition specifies a range, if the input condition, if it specifies a range, one valid and two invalid equivalence class are defined. Okay, one valid and, like for example here, one valid and two invalid class. One valid and two invalid classes are defined. Okay, if the input condition that specifies the range means, like for example, 19, 19 age, 19 to 60 age, the range. So for that, this is the range, valid range. This is the valid, and the invalid means, for example, 0 to 18, then 60, 61, 61 above. This is invalid. Then similar to, if the input conditions requires a specific value, one valid and two two invalid equivalence classes are defined. It is also same. If the input condition specifies a member of the set, member of the set, one valid and one invalid classes are defined. If the input condition is a boolean, if it is a boolean, one valid and one invalid classes are defined. Boolean means 1 or 0. So by applying these guidelines, we can derive the equivalence classes. So this is the example. So here you can see at the equivalence, at the time of testing, the test 4 and test 12 are the valid input values. Test 4 and test 4 and 12 are the invalid input values here. This is 4, 12. These are the invalid values, and 7 is the valid one. Okay, this one is valid. It is easy to test the input ranges 6 to 10, but harder to test the input that ranges from, if it is a large range, 2 to 600. So testing will be easy in the case of lesser test cases, but you should be very careful for the large, like for example, the range from 2 to 1000, 2 to 1000 means this range you have to test. So it will be, means you have to use different other methods, boundary value analysis and all. Assuming if the valid input is 7, if the valid input is 7, that means you believe that the developer coded the correct valid range. Okay, so the range is what? 6 to 10. So in the 6 to 10 range, you are testing with a one input value, that is 7. And if, for this particular input, if it is accepting, then it is a valid. It is a valid. So that is the, to check the range. Suppose if the range is, the size is very large, suppose 2 to 600 or 2 to 1000, then it will be difficult. You have to apply the other different approaches and your different methods, and you have to do the testing. It one testing, one method, it is not possible. You have to apply. That's why different levels of testing, different methods you have to use. Then only you can cover the number of defects. That boundary value analysis. In boundary value analysis, it is widely recognized that the input values at the extreme ends of input domain that causes the more errors in the system. Like for example, in the 6 to 10 range, the boundary means what here? 5 and 7 boundary values. Boundary values that causes more errors in the system, the more application errors occurs at the boundaries of the input domain. Suppose if it is a large range like 19 to 60, then here 20, 18 means here this is one test case. Boundary value you have to take. Like for example, for 18, if you write a one test case of 18, this invalid input, then you have to show it is invalid, and for this boundary value it is a valid, invalid. Means you have to take the in boundary values, so that this is means after the equivalence class partitioning, you have to apply for the boundary value analysis also. The different you have to use different methods to cover the maximum defects. Boundary value analysis testing technique is used to identify the errors at the boundaries rather than finding those exist in the center of the input domain. So in the center means here from like 19 to in the 60 this range. Okay. So instead of checking the 40 value means that you covered in the equivalence class partitioning. So with the boundary value analysis method, you cover the boundary values. Boundary value. So boundary value analysis is a next part of the equivalence partitioning. So yeah, it is extension. We can say it is extension or next part of the equivalence class partitioning for designing the test cases, where the test cases are selected at the edges of the equivalence class. At the edges of equivalence class. The boundary value analysis is the process of testing between the extreme ends or the boundaries between the partitions of input values. The boundaries between the partitions of the input values. So for this boundary value analysis, the process of testing between the extreme ends, as just now I told about extreme ends means from 19 to 60 range, the extreme ends are like here 59, 59, 61. These are the extreme end values. And here 20 and 18. Okay. So in this case, what are the valid? This 20 is valid, 59 is valid, and 18 and 61s are invalid. 81 and so this one, this is invalid, and here this is also 61, 61 also invalid. So like for example, for this range 19 to 20, 19 to 60, 19 to 60 range, for 19 to 60 range, we can write the 4 test cases for 18, 20, 59 and 61. Means if you provide input 18, then it should be invalid. For 20, it is valid. Boundary value, we are checking the boundary values. 59, just cross check, means the developer has done the coding or the coding of the application. Your job is to test whether for particular input your software is working or not. For 59, it should give valid, and for 61, invalid. Okay. So in this way, you have to cover the invalid or valid values. So example, so So these extreme ends like start, end, or lower, upper, maximum, minimum, just inside, just outside values are called boundary values like 18, 20, 59, 61. These are all called boundary values analysis testing. Suppose you have to you have a very important tool at the office that accepts a valid username and password field to work on the tool, and it accepts a minimum 8 characters and maximum 12 characters. It accepts the minimum 8 and maximum range 8 to 12, minimum 8 and maximum 12 characters. So the valid range is 8 to 12 and invalid range is less than 7, 13 or more than 13. So for boundary value analysis, so this is the valid 8 to 12 is the valid partition. 8 to 12 is the valid. Invalid means less than 8, like 7. So this is invalid. 13 is also invalid. Hmm? More than 12 invalid partition. So write the test cases for valid partition value and invalid partition value and exact boundary values. So test case 1 is that consider the password length less than 8. One test case is that to provide a password of the length less than 8 means it is invalid. It is a invalid. Then consider a password length exactly 8 means it is valid. Means you are providing a 8 uh, 8 characters. Then consider the length between 9 and 11. So that is also valid. Consider the length exactly 12. That is also working invalid. And suppose if it is more than 12, then it is invalid. That is invalid. Okay. So this is how we rate the test cases. Means for each test case, we'll find out whether means it should work. Like whether 5 test cases are there, and the tester will provide like a less than 8 characters. Less than means like suppose 6 character. Then it is invalid. It should the expected output is invalid, and it should not accept. Okay. In testing, we'll compare the expected and actual. Expected and actual, it should match. For this test case, for this it is invalid. Expected is, what is the expected? Less than, our condition is that 8 to 12 are valid characters. 8 to 12 the length. If we provide the less than 8, what is expected? It's invalid. Okay, it should not accept, invalid. And when the tester tests the application, so the whatever the result he gets actual, both it should be equal, expected and actual. Then only we can say the test case is passed. The test case is passed or failed. Suppose if for less than 8, if it is accepting, if the value does not match, then the test case is failed. The test case is failed. Okay, so this is all about the equivalence class partitioning and boundary value techniques of the black box testing method. Okay, so the other different techniques we'll discuss tomorrow, and